large powers using binomial expansion. So what happens when Pascal's triangle becomes impossible to use? Sometimes you might be asked to find the coefficient of a term from a binomial expansion that has a very large power. Writing out Pascal's 40th triangle to the 40th row would be inefficient, to say the least. So what you use is the formula for combinations. Now please bear in mind that this formula, this n, is the number of things you're picking from, or in this case the power, right? This is the power. And this has to do with the degree of the term. This means if you're looking at something like 2 choose 1, that would be an expansion where it's something squared, and that would correspond in Pascal's triangle to this 2 here. Row 2, and then entry 1, 0, 1, right? So just here's an example. Find the b to the 34th term in this expansion. Now we know that's going to be 2a times a negative 3b, right? And we know that this is going to be to the 34th power. Why? Because it's got to be the b to the 34th. How do we figure out what to raise the other term to? Well, we take 57 minus 34, which works out to be 23, and that becomes the power of this. Now, doing out Pascal's triangle to 57 rows, not going to do it. So here's what happens. 57, and then 57 because of the power that we're raising it to, choose 34. Now, it turns out that if you did 57 choose 34 or you did 57 choose 23, you'd get the same thing, but I'll show you that in just a sec. Now, negative 3 to the 34th and 2 to the 23rd you can figure out. That's going to be in those two to be numbers. I'm just going to run through how to find this. So this would be, using a formula, 57 factorial over 57 minus, there we go, 34, then factorial, times 34 factorial. Now the factorial is the same as saying 57 times 56 times 55. There are buttons on the calculator you can use for that. If you don't have a calculator and you just want to leave your expansion like that, as your answer like that, that's fine. So this ends up being 57 factorial over 57 minus 34 is 23 factorial times 34 factorial. You can figure out that number using your calculator pretty easily. But it works out to a rather large number. Now please bear in mind, if you were to, let's say, quote unquote, mess this up, and let's say you did 57 choose 23 instead, well, that would be 57 over 57 minus 23 factorial times 23 factorial. But if you simplified that, guess what you get? 57 minus 23. These are the same. That means it doesn't matter when you're picking what power you use. So, x to the 46th term in the expansion of x plus 3 to the 90th. Well, we know that that's going to be 90. Choose. Now, we already talked about this. It doesn't matter, so I'm just going to say 46 because that's what's given to us. Times x, and we know it's got to be the 46th, times a positive 3 to the, what? 90 minus 46, or 44th power. You can figure out what 3 to the 44th is, and we'll actually do that this time. 3 to the 44th, which is a huge number. Best we'll just leave it like this. So the answer would be 90 choose 46, x to the 46. So the actual coefficient would be 90 choose 46, which is a monstrous number, times 3 to the 44th. If you left your answer like that, I'd be fine because it's a monstrously big number. That's it.